Okay, so this is on page 207. Okay, it's a probability section. Okay, in this section there are two parts. One part is about what? Probability. Okay, the second part it is about what? False positive, false negative. Okay, so at the first let me assign the pages we're going to cover for section 16, and then we'll do the first part of section 16, probability. Okay, all right. Entire page of 207, I want you to do it, okay? And also we need to know what is a frequency table, okay? And then count the numbers, frequencies, and then figure out the probabilities, proportions, okay? So page 207, I will let you guys read through this page and also work on the questions by yourself, okay? All right, so entire page 207, page 208, entire page. Okay, you're going to answer these questions. Okay. Page 209, entire page. Okay, we'll talk about what is a probability. Okay, how to find the probability. Okay. Page 210, entire page. Yeah, probability operations, not and or. Okay. Page 211, entire page. Okay. Yeah, we'll talk about conditional probability. All right. Page 212, entire page. Okay. So one question is about eye color. You can try this. Okay. I will need you to do this as well. Smoking part is also, practice question. So entire page 212. Okay. So these are the pages for the probability. Okay. Now let's come to page 216. Okay, yeah, this is the second part of this section. It's about false positive, false negative. I would say the entire page 216, entire page 217, entire page 218. And entire page 219. Okay, so that's it. Okay, that's it for section 16. Okay, all right, so let's go back to page, I would say, what page? 209. Okay, we'll talk about the probability. Okay, probability. All right, so I'm going to ask a volunteer to read this top paragraph, this entire example 1, and this entire example 2. You're going to read everything above the questions, okay? Whose turn? Andrew.
If you flip a fair coin, what's the probability of landing with heads up? You might answer 50-50 or 1/2. There are only two ways that coin can land, heads or tails. We're looking for one of those two, so the probability is half. Probably the chance a specific event may occur is commonly expressed as a ratio. Let's think through another example, rolling a 6-sided pair into the die. Example 1, what is the probability of rolling a 5? Number of ways to get a 5 over the total numbers of possible outcomes. And that would equal 1 over 6, with 1.67, or 16.7%. Example 2, what is the probability of rolling an even number? Number of ways to get an even number over the total number of possible outcomes. Number 6 equals 1/2 equals 0.5%.
Okay, very good, thanks. Okay, so how do you understand probability? The chance that some event may happen. Okay, so say for example, what is the probability that today it's going to be rain? Okay, nobody knows it until it's rain or not. Okay, so on the website weather.com it says 30% is going to rain. Means what? There's 30% chance that this event may happen, right? So yeah, so this is how we understand probability briefly. Okay, yeah, they use this coin example. Also they're using what? The die question, right? The die question. Well, if we look at how to find a probability, okay, well here, this is the definition for probability. You may want to highlight this, okay? Yeah, it is a chance that a specific event may occur and is commonly expressed as a ratio, okay, just like the rain problem, okay, where, the die rolling or something, right? Okay, so these examples tell us how to find a probability of of some events. This is of rolling an even number. So how to find the probability? Okay, if we can summarize the method, it is going to be what? The number of the ways to get this event divided by what? Total number of possible outcomes. Okay, yeah, total number of possible outcomes. So if we're rolling a die, how many possible outcomes do we have every time? Only 6 possible outcomes. 1, 2, 3, 4, 5, 6. Do we have a chance to roll a 7? The chance is 0, okay? So there are some questions. So number 3, what is the probability of rolling a 7? You say 0, because there's no way, right? There's no way. Unless this die is a default, like a, how do we call that? A bad one, right? Otherwise there's no chance, okay? And then see, rolling a 5, how many ways can we get a 5? It's just one way we can get a 5. Once we roll it, we get a 5, okay? And divide by total number of possible outcomes, 6 of them. So there's only 16.7% of the chance that we may get a 5 when we roll die. And what is the chance to get an even number? We may have 2 or 4 or 6, right? So 3 possible, three of them, right? 3 of the even numbers. Divide by the total possible outcome, which is 6. So that means there will be 50% we roll an even number, right? Because the die has 3 odd numbers, 3 even numbers. So it's a 50-50%, right? So if you roll die, either even number or what? Odd number. So that the chance is what? 50th percentile, right? 50th, okay, yeah, 50%, okay. Okay, so, well, we're using those examples, okay, so to have a brief idea. Now this is the rules of probability, okay, rule of probability. I'm going to ask a volunteer to read this entire gray box. Whose turn? Leila?
Rules of probability. Probability of an event E equals the number of ways E can occur divided by the total number of positive outcomes. So any probability always must be between 0 and 1 and inclusive. 0 is less than or equal to probability of event greater than 1. Less than 1.
Yeah, less than equal, less or equals to, yeah.
3. The sum of the probabilities of all the possibilities is 1 or 100%.
Okay, very good, okay? So let's talk about them quickly, okay? To find the probability of an even E equals number of the ways even E can occur. Divide by what? Total number of the possible outcomes. We just use that 2 examples, right? We can see that, right? Okay, this is something that I want to emphasize, okay? Any probability must be a number between 0 and 1, okay? So probability of an event is between 0 and 1, maybe 0, maybe 1. So when the probability of an event equals 0, what does that mean? The chance that this event is going to be happening is 0, no chance, okay? So when the probability equals 1, that means what? In percentage, 1 equals what? 100%. So that means the chance that that event is going to happen anyway, right? For sure, 100%, okay? And a lot of cases, the probability is what? Between 0 and 1, okay? Because in decimal numbers, that's between 0% to what? 100%, okay? So this thing is going to happen or not. We have a percentage between 0 and 1, okay? So this is something that I want you guys to remind us, to remember this, because later when you do the calculations, your result for a probability must be between 0 and 1, okay? Maybe 0 or 1 or, between. If your result for a probability is negative 0.5, can that happen? Negative 50%? There's no way, okay? So you have to, pay attention to this. Oh, probability, if I get a negative something, or like over 1, you get a 200, like a 1.5, that's 150%. No, okay? Your result must be between 0 and 1, okay? And then the sum of the probability of all unique probability is 1. How to understand this? We roll a die, okay? There are 6 possible outcomes, right? What is the chance that we get a 1? 1 over 6, that's a chance. What is the chance we get a number 2? 1 over 6. The chance we get 3, 4, 5, and 6 for each of those events, that's 1 over 6, right? So the sum of those probabilities must equal what? 100%. You guys? Okay. So these are the rules of the probability. Okay. Well, now let's turn to page 210. Okay. So we know about how to compute the probability, and then there are several different types of the probability that we need to know. Okay. So there are 4 types. Okay. Not probability, and probability, or probability, and the last one is what? Conditional probability. You need to master all of these 4 types of the probability. You have to, okay? Alright, so let's look at these types one by one, okay? Well, I would say that we're going to use this police officer question, okay, to go over these types of the probability problem, okay? So, at first, okay, let's fill out this table and try to fill the table, okay? And then we will answer some questions, okay? So, the table. Let's look at the table. There are 200 police officers, okay? And among the police officers, we divide them into male police officer and female, right? Yes, we can, okay? From gender, right? From the gender, we can divide them into male and female. Well, also we could divide those police officers by what? These criteria: promoted or not promoted, right? Okay. So how to fill the table, everyone? In this direction, in the row direction, there are 30 male officers were promoted. 90 male officers were not promoted. So, in total, there are how many male police officers? 120. Whatever they are promoted or not promoted, they're male, 120, right? So, female police officer in total, how many? Yeah, 20 plus 60 give us 80. And then we can check the sum of male and female is indeed 200, right? Alright, that's in the horizontal direction. In the vertical direction, for promoted police officers, 30 of them are male, 20 of them are female. In total, how many police officers were promoted? 50. And how about those who were not promoted in total? 150. So is this sum equals 200? Yes or no? Yes. Okay, yes. Alright, so now let's look at, the table is a review of table. Let's answer some questions. Okay. Question 3. I'm going to ask a volunteer to read the question for us. Stephanie, can you read question 3 for us?
What is the probability a police officer was not promoted in the last year? This group of officers is also called
complement
of the group of promoted officers.
Okay, very good. Thanks. Okay, so find the probability of a police officer was not promoted in the last year. So how to find the probability? Remember, the probability is always numbers of the events divided by what? Total possible outcomes, right? So police officers were not promoted. How many of them? How many of them were not promoted? 150. Out of, in total, how many police officers? 200. So equals what? 70, I get a 0.75, which is what? 75%, right? 75%. So this is one way to do it. This is the most straightforward way. Do you have another way to do the problem? Let's try question 2 as well. What is the probability a police officer selected at random was promoted last year? What is the chance? What? 50 divided by what? 200 give us what? 0.25, that's what? 25%. Right? 25% was promoted, 75% was not promoted. You see? The sum of these two equals what? 100, right? So this is why it says this group, what group? Not promoted police officer, okay, is also a complement of the group of the promoted officer. So to get not promoted, the probability, either we use the number of not promoted divided by the total number of police officer, or we can do what? We use 1 minus what? The probability when the police officer was promoted, right? So 1 minus 25% will also give us what? 75%, because 1 equals 100%, right? So either this or that, okay? You guys, do you see that? Okay. All right, so if we summarize, what is the rule for using not when calculating probability? What is the rule? What is the rule, guys? Okay, we may say what? Subtract the probability that it does occur from 1. Okay, like subtract the probability that it does occur, okay, they were promoted from what? From 1. Okay, yeah, from 100%. Okay, so I would say subtract, okay, the probability, okay, that it does occur from 1, okay, what is 1? 100%, right? This is the first type. What do you feel? Not that bad, right? So not, okay, how to find the probability? Find the probability that it does occur, and then subtract that probability from what? 100%. Or if you can count the number of the nots, right, then divide by the total number. That's also fine. Either way. Do you see either way? Either way. All right, so now let's look at the next type. It's called a AND. Okay? Yeah. AND. So we have question 4 and 5. Okay, 4 and 5. I would say that let's do question 4. Okay? So I'm going to ask a volunteer to read the question 4 fast. Whose turn? Helen?
Find the probability of randomly selecting an officer who is a woman and was promoted. And means that both criteria must be met.
Okay, good. Probability that an officer is woman and was promoted. Both criteria must be met. Woman and was promoted. Which number from this table satisfy it is both woman and was promoted? Do you see 20 here? Because this number, it is in the intersection of this criteria and this criteria, right? So 20 are for both women and promoted. So let me use what? 20 divided by what? 200, which is the total number of police officer, give us what? 0.1, right? So 0.1 is what? 10%. Okay. Question 5. Let's do it quickly. An officer is man and also was promoted. Okay. So what is the probability? Man and was promoted. Do you find the number? 30, right? 30 out of what? 200 gave us what? I would say this is 0.15, right? You get 0.15, 15%. Okay? Alright, so what is the rule for using AND when calculating probability? AND. Yeah, so what? Locate, circle each area in the table that represent and probability. Yeah, this is another question, okay? So to find any probability, the rule is what? Taking the number which is on the intersection that meet both criteria, okay? So let me see whether there is a summarize of that or not. Okay, so I think we do, okay? So, yeah, so here I'm going to write this, okay? Take the value, okay, at the intersection of the criterias, okay, of the criterias, and divide by the total outcome, okay, and write it here, divide by the total outcomes. You guys agree with this? On the intersection, that meet both criteria, and then divide by what? The total outcomes for and. Everyone? Alright, so this is the second type. Okay, now let's move on to the third type. It's called OR. Okay, OR. So let's look at question 7. Irma, can you read question 7 for us?
What is the probability of randomly selecting a police officer whose female or was promoted? Or means either criterion is met. We have circled these values in the table. Be careful not to count the 20 officers who are female and promoted twice.
Okay, good. Okay. Find probability an officer is a female or was promoted. So there are two criteria, right? Female is one criteria, and then was promoted was criteria. So how many police officers satisfy either this or that? So I would say all female police officers satisfy their female, right? So female. So how many of them in total for female? 20 plus 60 give us what? 80, right? How many police officers they were promoted in total? 50, right? So I would say all of these 50 police officers satisfied their were promoted. But see guys, if we're adding the 80 by this 50, this 20 were counted how many times? Twice. Okay? So we cannot count, overcount these 20 for this and for both of the female and what? Promoted. So what do we do? Add the number of female police officer by the number of the what? Promoted police officer. And then because when we add the 80 and by 50, we count the 20 twice. So what do? Subtract by the one which were over-calculated, right? Overcount, okay? Subtract 20 once, okay? So we have 120 counted, okay? Divide by what? The total number, which is what? 200 police officer. You guys agree with this? Okay. So, what do we have on the top? $130 minus 20, 110. And then 200, this gives us what? 0.55. So this is what? 55%. Either this or that. Right? Alright, let's try to practice question 8 as well. Choose a police officer who is male or not promoted. Male or not promoted. I'm going to ask. So some of you guys tell me, okay? Damon? Question 8.
What is the probability of the randomly promoted police officer with male or not promoted?
Yeah, you want to answer the question. Male police officer, how many we have in total? 120, right? Not promoted police officer, I'm going to use a different color, okay? Where's my red pen? I hope you can see that, okay? So, male is one criteria, I would say, I'm going to circle this. Not promoted, this, right? So we're adding the 120 by what? What is the total of not promoted? 150. However, see, this 90 was count twice, right? So we're going to subtract by what? This 90 because it's over, count it, and then divide by what? 200 police officer, right? All right, so let's see, what is a percent? 90%, okay. 90% of police officer is either male or not promoted, okay. Now, if we're going to summarize the rule for using or probability, what is the rule? What do? Add up what? The values in the union of the criteria. What does union mean? Either this or that put together, right? So union, okay? And then being careful not to count the value in the intersection, what? Twice, okay? Then divide by what? The total, okay? So I'm going to write it here, okay? Add up the values in the union of the criteria. Okay. Being careful not to count the values in the intersection twice, okay, and divide by the total. Right? So it's just like add up those unions and then, make sure that we subtract the overcounted value in the intersection and then divide by the total. Right? So this is the third type, the or. Okay? Last type is called what? Conditional probability. I'm going to ask a volunteer to read everything above the question 9. Okay? Whose turn? Even.
No, all of the probabilities so far have been out of the total of all possible events. We'd also be interested in probabilities dealing with specific situations or conditions. Conditional probabilities. Suppose we already know a condition before we look for a portion of interest. Consider a condition a change in the mentor. If a police officer is a man, what is the probability he was promoted? The condition is that he is a man, and this limits our total number of possibilities to the total number of men. The item of interest to only those officers or men and were promoted. The ratio becomes number of items of interest over the total number of possibilities equals proportion of interest over condition is equal to men and promoting over men.
Okay, good. Okay, good. The question is here. If a police officer is a man, what is the probability that he was promoted? So to find this probability, do we divide by the total 200 police officer? Yes or no? No, because we're talking about if the police officer is a man. So the police officer is a man is our condition. Okay, we're only talking about the probability out of this male police officer. Okay, so that's why we divide by the condition, which is a male police officer on the bottom. And then what is the chance that he is a man and also was promoted, right? So on the top, the portion of interest is for men and also promoted. Divide by what? Male police officer, right? Men. Guys, do you see that? Okay, so if blah, 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 this is what? Our condition, okay? So this type of condition, probability we call, they are what? Conditional probability, okay? So, there is somewhere says how to figure out when do we have a conditional probability problem. I will here to, say that there are some keywords, okay? So, if in a question there are what? Some keyword like what? If, blah, 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 or given, blah, 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 okay? So, if we encounter if sentence and a given sentence, those sentences give us what? The condition. Okay, so sometimes it's so hard to to tell. Is this question a conditional probability, and then how to do it? Check if there is an if sentence or given sentence. If so, those are the condition for us. Okay, and we always have to divide by what? The condition on the bottom. We don't divide by the total number. We divide by the condition. Then we check what is the portion of interest, and use portion of interest divide by what? Condition. Okay. So there are several questions, okay, so I'm going to, let's do some of them, okay, some of them. Alright, so let's say, let's try question 10, and also question 12. Let's do these two. Question 10, I'll read the question for us. If a police officer was promoted last year, what is the probability that a police officer is a woman? Do we have any if sentence in this probability problem? We do. If blah, blah, blah. If blah, blah, this gives us what? Condition, okay? So what is the condition? Promoted police officer, right? Promoted, okay? Promoted. So, how many police officers were promoted last year? 50. So, out of this 50 police officers who were promoted, what is the chance that the police officer is a woman? Out of the 50 police officers who were promoted, what is the chance that the police officer is a woman? 20, right? So 20 out of 50, right? Give us what? 0.4, which is what? 40%. You guys do see that? Okay, so we have to really pay attention to if there's if sentence or not. If so, if there's if sentence, oh yeah, it is conditional probability. We're not dividing 200 here. We're dividing by what? The condition. Okay. You guys clear about the question 10? Question 12. Okay, I'll read the question and I will let you think about it. What is the probability that a police officer is a man if he was promoted last year? Do you have any if sentence? You do. Condition. So, Christine, can you tell us how to do the question?
Yeah.
So, condition is promoted, right?
So there are 50 promoted.
Uh-huh.
That's nominated.
Uh-huh.
and 30 of them are male. That's in there.
Oh, yeah, conditions 50. Out of 50, 30 of them are male, right, and were promoted, right? So we use what? We use 30 out of 50, give us what? 0.6, 60%, okay? So for out of the promoted police officers, 60% are male, 40% are what? Female, right? You guys? Okay, sometimes we use if sentence, okay? Sometimes there are what? Given sentence, given blah blah, given blah blah. You know that given blah blah, those that sentence also give us a condition, okay? So pay attention to these keywords, alright? You guys? Okay. Alright, so this is the last type, conditional probability, okay? We need a lot of practice on this probability part, okay?